Hello everyone, welcome to Ramanujan School of Studies 0 to Infinity. In this series, we are doing higher school mathematics and this is for class 11th. The topic here we will discuss is quadratic equation and this is the lecture 3rd and here we discuss about the sum and products of roots. In previous class, we had learned graphical representation of quadratic equation. It means how we draw a graph of quadratic equation and its roots and the position of graph of quadratic equation with respect to x-axis and y-axis according to the nature of roots. So also here graphical meaning of the nature of roots. Next, we will learn about sum and product of roots of a quadratic equation, and we also know how to form a quadratic equation, and we analyze the roots on the graph. That is, when we change the roots of a quadratic equation, the shifting of graph we will discuss here. Now sum of roots. As we have a quadratic equation, suppose ax square plus bx plus c, this is equal to 0. This is a general form of quadratic equation. The necessary condition for a quadratic equation is a cannot be equal to 0. It has two roots. Suppose x1 is minus b plus under root d divided by 2a. This is first root, where d is equal to d is equal to, this is b square minus 4ac, that is discriminant. This d decide the nature of roots, and second root is x2 when we will take negative sign. So this is minus b minus root d divided by 2a. Now we have two roots of the quadratic equation as we already discussed in the previous class. Now if we add both the roots, that is x1 plus x2, so we have minus b plus root d divided by 2a plus minus b minus root d divided by 2a. Taking 2a as LCM, we can write here 2a minus b plus under root d minus b minus under root d. Here plus under root d and minus under root d cancel the effect of each other, so we can cancel these two terms. We can write here sum of roots x1 plus x2, this is equal to minus twice of b over twice of a, so this is minus b over a. So if we know the coefficient, the value of coefficient, that is a, b, c, we can find the sum of roots is minus b over a. So this is very important, so you have to learn this formula. Sum of roots is minus b over a, that is negative of the coefficient of x divided by the coefficient of x squared. So this is the sum of roots of quadratic equation. Now we have to find the product of the roots. So we have two roots as discussed, so we can write x1 into x2, this is the product, and this is minus b plus root d divided by 2a into minus b minus root d divided by 2a. Now on multiplication we can write here x1 into x2, this is equal to minus b plus root d, right, into minus b minus root d, and in denominator we have 2a into 2a, that is 4a square. Now suppose here alpha is equal to minus b and beta is equal to under root d. So we have alpha plus beta into alpha minus beta. So in the above expression we can write the factor of the multiplication of minus b plus root d into minus b minus root d on the formula alpha square minus beta square is equal to alpha plus beta into alpha minus beta. So we can write here this is equal to minus b to the power 2 minus root d, and d is under root b square minus 4ac. So we can write here root d to the power 2 divided by 4a square. Further, b square minus b square is, this is b square minus, this is root d, so we can write here d over 4a square. Now, what is the value of d? As we earlier discussed, d is under root b square, d is b square minus 4ac, so we can put here b square minus 4ac divided by 4a square. So, x1 into x2, this is equal to b square minus, if we open the bracket, we have minus b square and minus minus plus 4ac divided by 4a square. Now plus b square and minus b square is cancel out, so we can write here product of root x1 into x2 is 4ac divided by 4a square can be written as 4a into a. So 4a cancel out with its denominator 4a, so we have c over a. So product of root is the ratio of constant term to the coefficient of x squared, that is c over a. So this is the product of root. So we have two formula of sum of roots. This is equal to minus b over a, and product of root is c over a. So this is mandatory to you to learn these two formula. This is very important in the formation of quadratic equation. How to construct a quadratic equation? So we have general quadratic equation is ax square plus bx plus c, this is equal to 0. On dividing both sides of this equation by a, we can write here x square, okay, plus this is b over a into x plus c over a. Okay, so this is equal to 0. Now, as we have, suppose the equation has two roots, suppose alpha and beta. So alpha plus beta, sum of root is minus b over a, as we derive in the above slide, and product of root, that is alpha into beta, this is equal to c over a. Now transforming the general equation in the form of alpha and beta, that is in the roots, corresponding roots, we can write here x square minus, we can write this is minus b over a. Here minus into minus become plus, so there is no change in expression, into x plus c over a. Okay, so this is equal to 0. Now as we know that minus b over a is nothing but sum of roots, and here we already assume that alpha and beta are the roots of the quadratic equation, so we can write here x square minus, sum of roots can be written as alpha plus beta in place of minus b over a, so this is alpha plus beta into x plus c over a is product of root, that is alpha and beta. Now this can be factorized as x square minus alpha x minus beta x plus alpha beta, this is equal to 0. So taking here x as common, so we have x minus alpha. Again here we take minus beta as common, so we have x minus alpha. So further we can write this as x minus alpha into x minus beta, this is equal to 0. So we have, if we have two roots alpha and beta of a quadratic equation, the equation can be written as either in the form of factor, that is x plus alpha to alpha into x minus beta, this is one form, and in other form we can write here x square minus sum of roots, that is alpha into beta into x, alpha plus beta into x plus alpha beta. Basically both these form are the same, but their application is very useful in deciding the, in solving the questions in of the quadratic equation. So here hope you understand this concept here. Now if we have take an example means if you have to form a quadratic equation whose roots are 3 and minus 2. So you have alpha is equal to 3 and beta is equal to minus 2. So either you can write this in factorized form. So if alpha and beta are the roots of quadratic equation, so a quadratic equation can be written as alpha x minus alpha. So x minus alpha into x minus beta, this is equal to 0. So this is the quadratic equation whose roots are alpha and beta. Putting here alpha is equal to 3, so we can write x minus 3 into x minus, here roots beta is minus 2, so we can write here minus 2 in small bracket. Okay, so this is equal to 0. So x minus 3 into x plus 2, this is equal to 0. So this is the quadratic equation whose roots are minus 3 and whose roots are 3 and minus 2. In other form, we can write this as x square minus sum of roots, that is alpha plus beta into x plus product of roots. So this is alpha into beta, this is equal to 0. So we have x square minus sum of root is 3 minus 2. So we can write here 3 minus 2 into x plus product of root is 3 into minus 2. This is equal to 0. So equation becomes x square minus x plus 6. This is equal to 0. So whenever you have to ask about constructing a quadratic equation given its roots, then you can follow these two procedures. Okay, so this is very important and this is very easy. You see here x square minus x plus 6, this is nothing. This multiplication and this multiplication is same, that is if we multiply x minus 3 into x plus 2, we get the same x square minus x plus 6. So this can be achieved by splitting, this factor can be achieved by splitting the middle term of the quadratic equation, so both are the same. So here we see how to form a quadratic equation. Now we have some special cases in which direct questions will ask. Here construction on new quadratic equation, the condition here is a quadratic equation whose roots are reciprocal to the roots of given equation. Suppose alpha and beta are the roots of quadratic equation x square ax square plus bx plus c is equal to 0. So this can be written as x minus alpha into x minus beta. Okay, now here we have to form the equation whose roots are reciprocal to the roots of given equation, that is now we have to find equation of quadratic equation whose roots are 1 over alpha and 1 over beta. So moving to the standard calculation, that is x square minus sum of roots. So we have 1 over alpha plus 1 over beta, okay, plus into x plus product of roots. So 1 over alpha into 1 over beta, this is equal to 0. This is the required quadratic equation. So we can write here x square minus, we take the LCM, that is alpha beta. So in numerator we have beta plus alpha, okay, into x plus 1 over alpha beta, this is equal to 0. So putting the value of alpha plus beta into alpha beta, we can write here x square minus alpha plus beta is minus b over a. So we can write here minus b over a, and alpha beta is c over a. So we can write here c over a, okay, plus alpha beta is 1 over c over a. So further we can write here this is nothing but x square, okay, plus b over c into x, okay, plus this is a over c. So this is equal to 0. So equation become cx square plus bx plus a, this is equal to 0. So what we see here, the coefficient of x square become the constant term, that is a, that is this a here comes here, and the constant term become the coefficient of x square, that is c. So whenever the roots are reciprocal to each other, in this case we have to change the coefficient of x squared to constant term and the constant term to the coefficient of x squared. So if roots of alpha, we can write here, if roots of alpha quadratic equation ax square plus bx plus c is equal to 0, this is roots are alpha beta, then roots of quadratic equation whose roots are reciprocal to this equation can be written as cx square plus bx plus a. So there is interchange of terms, that is a and c, and it is noted here that there is no change in the middle term, that is the coefficient of x. So this is very important. Moving to the next, a quadratic equation whose roots are k more than that of the roots of a given equation. So if we have ax square plus bx plus c, this is equal to 0 and its roots are alpha and beta. Now we have to form a quadratic equation whose roots are alpha plus k and beta plus k. Okay, so sum of roots from here we can write here alpha plus beta is equal to minus b over a, and alpha into beta, this is equal to c over a. Now we have to find the roots whose sum are alpha plus k and beta plus k can be written as x square minus sum of roots. So we can write alpha plus k plus beta plus k, okay, sum of roots into x plus product of roots, so alpha plus k into beta plus k. So here we have to put alpha in place of alpha we have to alpha plus k, and in place of beta we have to beta plus k. So this is equal to 0. So upon solving we can write roots of this quadratic equation as x square minus, this is alpha plus beta, so we can write here minus b over a plus k, that is 2k, okay, plus c here into x, plus this is alpha into beta, see here alpha into beta plus alpha k plus beta k, so we take k as a common, so alpha k plus beta k, we have alpha plus beta plus k square, so this is equal to 0. Now see here, this is x square minus plus b over a into x minus 2 into k into x. Now this k square can be written here k square, okay. So alpha plus beta is again c over a, and plus k into alpha into beta is minus b over a. Now see here what happened here, this is x square minus 2kx plus k square, so this can be written as x minus k square, okay, right. Now here b over a plus in plus, and here b over a minus, so we can write here x into we can write here this is plus b over a into x minus k plus c over a. This is very important, and here we see that if we put the value of x when the roots is more than k, we here substitute x in x minus k in place of x. So if we put in place of x minus k, so the equation becomes, see here, a into x minus k square plus b into x minus k plus constant term, see this is equal to 0. So this is the quadratic equation, see here, this is quadratic equation whose roots are k more than the previous equation. So this is very important, and this derivation is also very important. So look at this and try to solve, try to sorry, try to derive these results yourself. So when roots are increased by k, we have to put x minus k in place of x, okay. So this is ax square, ax minus k square plus b into x minus k plus, see this is equal to 0. Now what is its graphical interpretation, see here we have to put x minus k in place of k, and roots are more than k. So if the previous roots are alpha and beta, so this is the graph. So this is alpha and this is beta. Now suppose roots are increased by k, so new roots may be alpha plus k, and this is alpha plus k and beta plus k. So the graph shift, suppose this is alpha plus k here, after increasing this is alpha plus k and this is beta plus k, beta plus k. So the new graph is like this. So upon increasing the root, the graph shifts toward right. So here the graphical interpretation is that when we put x minus k, that is we decrease the value of x by k, the graph is moved right by k units. This is very important and you should learn this. So this is the transformation of graph. Now moving to the next one, constructing a new quadratic equation. In this case where k is more than, already we have discussed, this is the k is more than that of the roots. So here we have k is, this is not more than, this is less than. So new roots, if ax square plus bx plus c, this is equal to 0, this is a quadratic equation and its roots are alpha and beta, and new roots are less than k. So the new roots are alpha minus k into beta minus k. So upon the same calculation what we have done here, like this, we have to put alpha plus beta and alpha into beta. We can say that if we put x plus k in place of x, we have the quadratic equation, that is ax plus k square plus b into x plus k plus c is 0. This is equal to 0 is a quadratic equation whose roots are k less than the quadratic roots of the quadratic equation ax square plus bx plus c. Now if we plot the graph, so suppose this is x and y axis and the roots are like this, this is alpha and beta. So new roots are alpha minus k and beta minus k. So here we can write this is alpha and this is beta. So suppose new roots are decreased by k, so this is beta minus k and this is alpha minus k. Okay, alpha minus k. So the new root, the new curve is like this. It means that the graph shift leftward by k units. So when we put x plus k in place of x, graph moves k unit leftward. So this is very important, and this type of transformation is very is applicable to all type of graph, not a single quadratic equation. It is also applicable of all type of real graph. So this is new, this is the new form, and I hope you understand this concept. If there is any problem in learning, then you can comment to me in the comment box, so that in next class we trying to remove all the doubts. Now next is a quadratic equation whose roots are k times the other that of the other roots. So if ax square plus bx plus c, this is equal to 0. So alpha beta are the roots. Now the new roots is k times, so new roots are k alpha and k beta. So the quadratic equation in this case, we have to put x over k in place of x. So we can write here a into x over k square plus b into x over k plus c. This is equal to 0. So this is the quadratic equation whose roots are k times of the previous. If the roots are diminished by k times, that is 1 over k of the time, then the quadratic equation can be written as xk in place of x. So we have a into axk to the power 2 plus b into xk plus c. This is equal to 0. So this quadratic equation has the root which is 1 by k times of the quadratic roots of the quadratic equation ax square plus bx plus c. So these are some transformation of the roots as per the quadratic equation. And here we also discuss the shifting of graph, when the graph, how the graph is shifted right and leftward. Okay, so for today we stop our class. Thanks for watching. In next class we will discuss about the condition of roots. So if you think this is really helpful to you, then please share this content and subscribe my channel so that we can make more and more quality videos. Thank you everyone. Have a good day.